Hey guys, welcome back to a new video today. Now, in our previous video with Docker, we went over getting started using Nginx and getting the Docker engine installed to our Linux Mint system. As you can see here, our container is still running. You're, doing our usual fuck around, find out kind of stuff. Now, the next step, well, we can still use Docker inside our command line here. We may want something that's a bit more either user-friendly, friendly for developers, basically going away from the command line interface and allowing more integrations, more streamlining, just making it easier across the board. This is where Portainer comes into play. Now, personally, I fucking love Portainer. I've used it for quite a few years now. I mean, shit, it's been at least 5 years. I used it with a couple friends. We would mess around with it. It's really helpful for administering your containers, administering network stacks, and getting a lot of stuff done, especially when it comes to doing Docker swarms or Kubernetes or Nomad, whatever orchestration engine you might use. It is super fucking helpful. So what we're going to do today is we're going to get Portainer installed, and then in later videos we're going to start showing off what we can really do with Portainer and Docker, or even just Docker if you know how to use the proper commands. So to get started, we're going to head over to Portainer dot, oh, I spelled that wrong. Portainer.io. Now, as you can see here, we're given the page for, Portainer and getting set up. We're going to head down to resources and then under learn documentation. And then from here, we're going to install Portainer Community Edition, also known as CE. I personally use Business Edition because a lot of the tools that Business Edition has are very helpful, and I plan on upgrading in the future when I'm not fucking poor. I digress. But if you can run Business Edition, you do get up to 5 nodes for free. I would highly recommend it. So we'll jump into Community Edition for today, and we'll set up a new Community Edition server installation. And because we're only running this on one server and we have not yet set up Docker Swarm, we're going to do Docker standalone. And we'll do it on Docker on Linux. And finally, you're given the documentation here. Now, this is very helpful, especially if you do run into issues. It's pretty easy to do, so it's 2 commands here. See if we can mount this to the side. And mount this one right here. Now next, what we're going to do is we're going to scroll down into the deployment section here, and we're going to create a Docker volume. So we'll go ahead and clear our terminal here, and Docker volume create Portainer data. Now what this does is it essentially creates a, this essentially creates a virtual disk that Docker can use to store application data in. You can create multiple volumes. Multiple volumes can be mounted to one service. However, you cannot mount multiple volumes to one single folder. So if you have volume 1, volume 2, volume 3, they cannot all be mounted to like home/Yehod's Jake. So next, we're going to run the container image. This is Docker space run space D for detach, so we don't want to immediately go into the container with a command line shell. And then we want to expose ports 8000, ports 9443, and then we want to set the name Portainer for the container running. And should this container ever fail, we want to always restart it. And then finally, we're going to mount var run docker sock, also known as socket. We'll mount the volume Portainer data to a folder in Portainer. And finally, we want to target this image. I'll show you guys all that here. So to touch on as well, if you take a look here, /var/run/docker.sock is what's known as the Docker socket. Utilizing this is what will allow other containers, other images to essentially communicate with Docker directly. And what this can do is, one, Portainer needs this to actually work. Without it, Portainer really can't do much unless you have a remote server. But two, it's kind of like an API essentially. So Portainer communicates to Docker. Portainer might say, hey, let's create a new container with this image, these parameters, yada yada yada. Docker says, okay, great, here's the status of that, here's what we're doing. It gives feedback, essentially creating a communication pipeline between the container image and Docker. And multiple different applications on Linux can also create sockets for this specific matter. But because we're only going into Docker today, we'll only be doing this. So enter, and just like that, Portainer, the image, it starts downloading. We'll give this here a few minutes and let it do its job. Okay, now we've successfully downloaded Portainer, and if we check again, Docker container ls, Portainer is now running. So now we can access it with localhost 9443. Oh, we need HTTPS. Now I should note that you should only be using localhost if you're doing all this I can't speak, directly on the server. If you're running, a server and this is, being done remote, you should be accessing it from the server's IP. So we'll go ahead advanced, and accept the risk. Now we'll select a new admin and password. We'll just set it as password, I guess. Fine, password. We're all about security here. And we'll deselect this and go ahead and create user. Save this. And now we're going to do get started. And now what that does is it brings us to our current environment, which is hosted directly on the server. Dismiss. So if we go live connect, we can now see the two containers that are running, this being Portainer and our new web server. If we go into here into the web server, we can do all sorts of fun stuff like stopping it, we can kill it, restart the container, we can put it on pause. If we want to recreate the container for whatever reason, if we want to edit or duplicate that same container, or we can create a new image from this. There's all sorts of fun things we can do. So now that Portainer has successfully been deployed to our server, we can now manage our containers with, we can now manage Docker and our containers much more easier, and it comes with so much more fun, including when we run stacks here. You're essentially using Docker Compose, which we have not gotten into just yet, but instead of deploying one container, you are deploying a team of containers that may all work together. Like, for example, GitLab runs with a stack or a Docker Compose file. So it runs a database server, it runs its front end, it runs a reverse proxy, and it's all kind of, its own little pod or bubble, if you will. And then we also have images where this is, oh, no, that's networks. We have images here, which is essentially the install file. So like when you go to install Minecraft, minecraft.exe, this is basically what this is. So you can think of it like nginx.exe. We run that image, then we configure that image, then we deploy that image. And then here we have our networks. So if we want containers to be isolated to only communicate with each other, if we want them to communicate with the outside world, if we want them to do both, whatever it may be, we can all configure that here and configure different networks on top of each other. Volumes here, as we explained earlier, are basically virtual disks that we mount into our containers so that they can store persistent data. Keep in mind when you run Docker images, or Docker containers, I should say, once you restart them, they will start brand new as if they came right out of the box. Hence why you want to A, either use a database server, or B, you want to use volumes. If, for example, WordPress isn't exactly a good example, but I'll use it anyways. When you want to get started with WordPress, when you start a new WordPress image, which we'll get into in another video, what this does is you're left with a brand new WordPress instance. In order for you to actually have this stay persistent on restarts, you have to tell WordPress, here's a database server, here's a storage volume. go wild, set yourself back up on each restart. We also have events here, which shows what's going on with the server, basically, what has been going on. And then we can check out host information here, so we can see we're running on Linux Mint, what kernel we're on, how many CPUs and memory there is. Obviously not a whole lot here. And then we can also configure users, environments, and registries, which we'll get into much later. So I figured this was a good tie-in to show you guys how to basically manage your containers easier as we move on further with these Docker videos. So thank you for watching. Make sure to leave a comment, a like, and subscribe, and make sure to let me know if you guys want to see any more videos. Thanks for watching, and have a good day.